Welcome. My name is David Boike. This is modeling tricks my relational database never taught me. It's just kind of my experiences with how I've beat my head against the wall with SQL Server, but it really applies to any relational database, and kind of how you can get through that with Raven, and hopefully we'll learn some stuff about modeling on the way. So a little bit about me. I'm a principal consultant with ILM Professional Services in the Twin Cities. We're a RavenDB partner, and I'm also the author of Learning NServiceBus. I'm a husband, father, geek, amateur beer brewer. That beer brewer thing is probably the most important thing on that slide. So this is how I think of SQL Server. Big brother. It's the big guy that's forcing you to keep all of your data in nice little rows and columns like Mara was thinking about. And as a result, that's how we've come to think about like everything. We think about rows and columns. And that was okay when SQL Server was created and all of our applications looked like this. My first internship or full-time job out of college, I was going to write web applications, and they said, okay, now you're going to do your timesheet, and they kicked me to an AS400 app like this, and I was like, what? It was a financial company, though, so I really shouldn't have been surprised. But that's not the type of application we have today. So why do we stick with SQL Server? Is it to save disk space? Oren has trotted out these kind of statistics several times, but when SQL Server first appeared, it cost $189,000 per gigabyte. Then when Microsoft SQL Server 1.0 appeared in 1989, that came down to just under $8,000 per gigabyte. But of course now, in November 2013, according to the random thing I looked up on the interwebs, just over 4 cents per gigabyte. So obviously, really saving space is not really a great reason to pick a storage medium anymore. So then there's this. I don't think this could be any more true. Because SQL Server forces us to jump through all these hoops and gymnastics in order to just store stuff in an unnatural way, performance problems can easily crop up. And then there's Entity Framework. I was talking with some of you guys at breakfast yesterday about how I kind of hate, if you read some of the Microsoft training manuals for the certifications, they're like, okay, you shall create a new project. You shall create a new Entity Framework. You shall create a new SQL Server database, and then you shall ask the business what the requirements are. That really, really bugs me because it just locks you into this Microsoft-centric bubble that you can't escape from, and you probably lose out on the best solution along the way. Now, someone's probably going to tweet that, and I'll never get an MVP award, but I guess I can live with that. So if you have an application like this, I say go ahead and use SQL Server. This is a place where SQL Server is great. This is not the kind of application I like to build. That sucks. So if SQL Server is big brother, then what is RavenDB? RavenDB is the dude. And so what is RavenDB? I'm assuming most of you here have probably heard of RavenDB before. I've also given this talk at a .NET user group where I'm guessing they didn't. Has anyone by chance not heard of RavenDB in this room? One guy, all right. So we all know it's a fully transactional, blah, 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 API, link, safe by default, powerful indexes, replication charting, fraction of SQL Server's cost, and that's one of the things I really like to bring up with business stakeholders. So Raven Enterprise is, if I can find my mouse back, Raven Enterprise, I think, is, $459 per core per year. SQL Server 2012 Enterprise Edition is almost $7,000 per core, almost 15 times as much. I'm not a Microsoft licensing expert, but even then, SQL Server 2012 would have to last you till 2029, and I don't think it will. Also, SQL is not getting better at the same rate as Raven, in my opinion. So the biggest thing I think about RavenDB is it's just awesome to work with, as many of you probably already know. It just forces you to think a little bit differently about your data access. And mastering Raven, in my opinion, comes down to 2 main concepts: effective document modeling and the use of indexes. And if you wanted to learn about use of indexes, that's not what this talk is about, I'm sorry. So coming from a relational background, we're tempted to take the blue pill and apply our relational modeling concepts to a document-oriented world. And don't do that. And Oren posted an article on his blog once that contained this example from a company who tried to use, I forget which document database it was, Cassandra or something like that, where they basically tried to stuff all of the things into one document. And so this was one document with a TV show containing many seasons, containing many episodes, containing many reviews, containing many cast members. And when you think about one of those shows was General Hospital, which aired over 12,000 episodes over the course of 50 plus seasons and denormalized the actors of every single one. I mean, we're talking about probably a gigabyte document, and of course that's not going to work well. So we have to think about how can we effectively model without getting ourselves in the throw all the things in the document trap. So hopefully this presentation will give you the confidence to take the red pill. So we'll start with inheritance, or back to ComSci 101. So there's a bunch of different ways to do inheritance in SQL Server, at least some of the ones that I've run across. The first way is pretty naive, and it's basically to store everything flat. So you have an ID and a type and some base properties, and they're not nullable or nullable or whatever you need them to be. And then everything else you have for every other possible derived class has to be a property that is nullable because it might not exist based on the class you're trying to instantiate. This is crappy because you lose a lot of SQL's ability to tell you that your data is good based on its checks of nullable and stuff like that. Plus, it's just a mess to try to look through. And before I go any farther, I really hate all the cliche polymorphism examples. So every time you see polymorphism anywhere, it's probably animals, or cars, or more broadly, machines, or shapes, circle, rectangle, square. Now answer me this, does a square inherit from a rectangle, or does a rectangle inherit from a square? Does it? So I'm not going to do any of that stuff. And maybe it's not the best example in the world, but I mentioned that I was an amateur beer brewer. So we're going to go with that. Because it's delicious and instructive. You get that, Judah? Yeah. So the other way we can go is having a table per class, where we have a base table beer that's got the base properties, type, name, alcohol by volume, and IBUs. And then we have separate tables to have each of the derived classes, in this case, ale, lager, and stout. I don't know exactly what properties ale, lager, and stout might have, which is why maybe it's deliciousness. That would be on the base class. So I'm not sure that this is exactly the perfect polymorphism inheritance example, but whatever, work with me. So the problem with this, obviously, is if you're going to query for a beer of unknown type, you have to first query your beer table, look at the type, and then decide which table you're going to query another one from so that you can hydrate your whole object. Not the most efficient thing on the planet, and if you want to do it in one round trip to the server, you probably have to write a stored procedure, which isn't my first choice. So you could try to optimize that by taking the base table out of that and plugging all of the properties into the derived tables and having basically a table per top level class. And I think NHibernate allows this option when you're using that. So Lager, for instance, has the beer ID and the name and all that stuff, plus its Lager properties. But then, of course, you have 3 different tables and they really have no connection whatsoever. So if you have no idea if it's an ale or a lager or a stout, you don't even have any idea where to query, and you're kind of screwed. So then we get into the really kind of silly and goofy examples. This concept of extended attributes I picked up from a product I worked with like 8 or 9 years ago. This extended attributes thing where you have 2 basically varchar fields at the end. And in the attribute names, you stuff basically your property names and this indexing information that tells you how to get at them. So attribute foo is a string, and it starts at index 0, and it's 11 long. And attribute int val is a string, because everything's a string, and starts at position 11 and is 2 characters long. And then the attribute values just put all the attributes together. And this all turns into a dictionary, and then you have to have a generic like get T in order to massage it back to the type you want. It's just a huge pain. Yes, it is.
Been there.
I tried to Google it last night and I can't find it anymore. Did it die?
No, well, it still exists in the wild.
That's awesome.
Yeah, we have a product exactly like this at my old job that's terrible having to deal with this crap.
One of the other consultants in my company is at a client, and they had to take information like this that I had put there, because it's my former employer, and put it into Raven, and he was quite angry with me.
Fun fact, I got carbon coated as a best practice around other projects that work.
Yeah, exactly.
Yeah.
So then probably a better thing than extended attributes is to go to XML attributes, where you put your really important properties that you need to be able to query on and join on and that sort of thing in actual columns. And then you just say, I'm going to dump everything else in this giant XML blob. And hypothetically, we should have some ability to query on the XML with an XML index. But do you ever really do that? Has anyone made an index on an XML blob before in a database? No? I've done it once. It sucked. The performance is not as great as Microsoft would have you believe.
You can do it with XML and a materialized view and index the view.
Ah. But then you have to wonder, so we're stuffing all of this XML into a column. Aren't we basically creating a document database in SQL Server anyway? And we're not getting any of the good effects out of it. So why do it? So Raven inheritance. I start with a beer list model just so we can see multiple of them. So we have an ID property and just a list of beers. And we have an abstract class beer model with the name and all the base properties. And then, of course, we have each derived class with the stuff that it needs. And how does that look in the database? I'm sorry, I'm showing old Studio, Judah. Forgive me. So we get this $type attribute that tells Raven, or JSON.NET really, how to deserialize it, and everything just works. So what can we learn from this? It just does. But in RavenDB, it's no big deal. But the key takeaway is that with RavenDB, we can model things just like they exist in real life, for the most part. So my second example is hierarchy, which SQL says they have a feature for. So no big deal. And I'm not really going to cover the hierarchy feature, but just more in a broad sense. So with this hierarchy, we basically normally think like a list of categories or a category tree. And so that's usually select star from category. Maybe you have a multi-tenant, so you have a site ID or something like that, and parent ID, and that'll get you one level worth of hierarchy. Or you can just select them all and put them into a big dictionary and mangle them yourself into a tree structure, and away you go. In Raven, we have a couple different possibilities. The first is that we can just say we're going to put everything inside one document. So we can just have a list of categories at the root called root categories in our category tree document model. And then each category can have an ID and a name and whatever else it needs, plus its own list of child categories. And so the entire thing can fit into one document. Now, if you're Amazon, you have a bajillion categories. Maybe that's not the way to go. Or if there's 30 megabytes worth of supporting information on every category, maybe that's not the way to go either. Or more importantly, if you have different people accessing different categories and changing them at different times for different reasons, then this might not be the way to go. But this is what the first way looks like. Everything's nested. So in the second way, we have a category class with the ID and the name, and this is its own document. And then we have a category tree that just shows the organization between the categories. And then a category ref that has a category ID and the list of child categories. So the category tree contains the category ref and the whole tree, and then the category contains presumably many more properties about what each category really means. And don't forget the default constructors. I'm omitting them for space here on the collections. So that's what this looks like. You have one big document that shows the tree structure. Then you have documents for each category with all of that information. So then we get into the problem of having to load it. With method 1, it's one document. We can just load it, no big deal. With method 2, we have multiple documents. So normally to load within collections, we can use this include with the string overload and use the comma to say, within the collection root categories, I want you to grab all the category IDs and include them and bring them all back in the same round trip to Raven. But it doesn't work recursively, and if Oren wanted to tell me I'm wrong on that, that'd be fantastic. But it works fine for one level. So that would allow us to show a page where we show one category level at a time. Another way you can do it is to get the tree directly, just one load. And then we can recursively build a list of IDs that we needed. Now we're not in Comp Sci 101 anymore, so you can do recursion on your own time. But then Raven will let you basically load all of those categories that you need at once. You can throw them in a dictionary. You can put them right on your view model if you really want, and output them from there. So what can we learn from that? And this is the big one, model documents by units of change and transactional boundaries. So in this case, a unit of change would guide our choice of hierarchy implementation. So if it's just like 3 people in a room together that can modify a small amount of categories, then it's fine to just put them all in one document. But if you have something like Amazon and there are maybe 100 different users modifying different categories at any one given time, or maybe one user is modifying a category while another person is moving it around, those are different reasons for change, then we should put them in different documents because a document is our level of acid for our use. And also think about actors in your use cases. So if it's an administrative person versus a public person, or even if it's a human versus an automatic one. Like when Itamar did his Stack Overflow in an hour talk, he has the question for each Stack Overflow question in one document, but then he has the stats in another document, so that every time you load the page and increment the stats, you're updating the stats document, but not the question document, because that has no reason for change. Also, always initialize collections and child objects. This is my personal rule because nobody likes a null reference exception. And also, we can have global singleton documents for configuration. When I'm helping people start with Raven, for some reason, they're like hardwired into this collection name /ID, and that's the only thing that can work. But we can have just site/configuration. It can be like one document where we store all the PayPal keys and the stuff we don't want to have in our source code. That's also great candidates for aggressive caching. So now duplication. So when I worked on my first RavenDB project, it was kind of a short, prove to me that you can do something with this before I give you free reign to use it on a bigger project. And I knocked it out of the park, of course. And as it was kind of like a mini CMS for mobile ad pages. So maybe they don't even need stuff like this anymore, but you have a mobile ad and it needs to go to a landing page that would work on the crappiest phone available. And so we need to have a very simple, a page builder for click here to call and image. And so it's a lot of drag and drop, just creating content. And I made a really useful function, which was duplicate. So they could take an existing page and duplicate it and make changes and then publish it and away they go. And so after I got done with that project, my boss came to me and he said, that duplication feature was really awesome. Can you do it for this other project, which was SQL Server, which was like 35 tables? And I was like, no. We could port it to Raven faster than I could actually make the duplication feature in SQL Server. So here's the WordPress entity relationship diagram, just as an example. This is actually a lot simpler than I thought it would be. WordPress uses so many of their tables for so many different things that you kind of lose any sort of concept of what is this table really like. Single responsibility principle is out the window. But just since you can't read, here's what the tables actually are. So some of the weird stuff in there, like post meta, they store things in there like edit lock and last edit. And like if you have discus comments in there, the discus thread ID goes in there and related posts, and it's like a dumping ground for plugins, and it's practically a document database. It's just dump stuff here. Term relationships are links to links, and term taxonomy. It's tough to say what it does. So if we wanted to copy a post, there are 3 tables involved. There's the posts and the post meta and the WP term relationships. Where is that one? Oh, posts, post meta, and term relationships. So should be pretty easy. More if we want to copy comments, of course, but we'll get to that in a little bit. So it's a fairly simple example. You create a new row in posts, selecting from the existing row in posts, and you store a new post ID. And then you have new rows in post meta with that post ID and new rows in term relationships with that post ID. But we're already touching 3 tables, probably within a transaction, a lot of locking going on. What if we wanted to copy a table related to term relationships? Because that already has a foreign key. So now we have to keep track of more than just the post ID that we're creating new IDs for. It's a whole list of them. What if an object graph spans dozens of tables, or 35 in my case? One of mine had a hierarchy in it with all the parent-child relationships. That would have really been impossible. What if post meta contains hidden IDs linking to other tables or other things that we have no way to know about because WordPress abused their ERD so much? P.S. Revisions are stored as additional rows in the post table. So a lot of stuff to try to duplicate a row or a record or a thing in any sort of SQL Server system. And of course, every time you then modify that system, you'll have to go back and modify that duplicate feature too. So how would we do it in Raven? This is just basically taking the WordPress columns and kind of throwing most of them in there. So author ID, post date, just that stuff you would expect for a blog post. Then we've got a list of strings for categories, and a list of strings for tags and series and related post IDs, etc. Links are a more complex type, so we can just throw stuff in there too. I mean, you guys we've all used Raven, right? So okay, so we know we can do this. But then comments, that gets to be interesting. Options for comments. We could just add them to WordPress post and have a giant list of comments. Would work great for my blog. 1, maybe 2 comments ever on a post. Read my blog, comment. Or we could have a document per comment. That's kind of the other extreme. So that would obviously give us our, if we're really paranoid about units of change, that would let someone like Scott Goo be pretty sure that he's never going to have a problem with many users commenting on his blog at the same time. But there are ways in between too. We could have a separate document for comments where we have WordPress post /1 and WordPress post /1 comments. We put all the comments in there. Or we could use something called capped documents where we split the comments and we cap them at a certain level. And what does this look like graphically? So for bounded contexts, something where the growth rate is not obscene and we know it's going to settle out to a comprehensible number, something unlike the Voron stats Oren shared previously, then we can just put them all in one separate document. And then we get our unit of change separation because me updating my post is very different than a user commenting on that post. If we have an unbounded context, if I'm Jeff Atwood or Scott Guthrie, then capped documents might be better. So we start off with post /1 comment /1, and we allow maybe up to 100 comments in there. And when it gets to 100 comments, we lock it, notice the padlock icon, and we create a new comments document, and we update post /1 to point directly to it, and we keep going. So at any time when we want to display the blog post, we can load post/1 and use the include feature to get the first page of comments and begin displaying them. And then we can do comment paging or infinite scroll or whatever we want to do, because each comment document will point to the one previous to it. Then the question becomes how to duplicate. There's probably a lot of different ways to do this, but the one I prefer is to use AutoMapper. And we can do this by initializing AutoMapper and saying we want to create a mapping between blog post and blog post, so that basically you're going to copy everything except on the ID member, ignore that. Because if we just took one blog post and we said, hey Raven, store this with another ID, it's going to get a little upset with us. So we need to copy it to a different object, preferably without serializing it to JSON and serializing it back. I can also decorate the model's ID property with the ignore attribute, but then you leak a dependency to AutoMapper in your models, which isn't always a good thing. And then I can load a post with raven.load blog post and get it back. And then I can create a duplicate just by saying mapper.map, map this post to a blog post. It gives it back to me, but the ID on the duplicate is null. And then I can say a Raven session, please store that duplicate, and it'll get blog post/2. So why duplicate? Well, obviously the first use case is the duplication function that my boss so desperately wanted, and I still don't think he has. Second one would be for auditing or history. There is an auditing bundle or a versioning bundle. Did someone in this room write it? Did you write it? No. Okay. That, of course, stores every single change you make to a document as a different version, but if you want more fine-grained, like this is an important event, so I need to make an auditing history of it at this point, you can do post/1/history and then a date time. So yeah, consider the versioning bundle if you want to audit every single modification. Preview. One of our clients, the CMS I think I mentioned yesterday, uses RavenDB entirely for their CMS. And so it's really easy to do a preview because you just take the current post, you duplicate it, you give it this temporary ID so nobody can guess it, you send the user to a new tab, and the code on the front end of the site is loading the exact same code paths as it would in real life. And so you know that that story is going to look like it is supposed to, and there's not going to be any weird, well, this worked in debug but not in production type of stuff. In this case, you should use the expiration bundle because you probably don't want that stuff hanging around forever. And then there's like a complex edit, publish, cancel. So if I have post/1, I can say I'm going to start a bunch of crazy edits to post/1. May take me several days or whatever. So I can duplicate it to post/1/edit/my username. I can do whatever I want to it over the course of however long it takes. Merging it back or whatever may be up to you, but that's a different concept. And then those edit documents can have an expiration too, so that they don't stick around for longer than a few months. And then when I'm done, I can simply use AutoMapper to map all of those properties from the new model back onto the old one. So what can we learn from duplication? First, I think, is thinking about duplication can help us to identify units of change, but it can't get us all the way. So when we were thinking about our comments, thinking about if we duplicate a blog post, would we want to duplicate the comments with it? That's the kind of question we can ask the business that they'll be more likely able to answer than, can you identify the units of change in the system for me? Also, make use of semantic IDs. I love them. I will use them all over the place, post/1/whatever, in order to make more sense of the documents in the database before I even look inside the document. And duplicating data enables many of those scenarios I mentioned. We need to think about possible document growth and think if we need to just have a separate document or capped documents or completely separate documents. And also we need to break down large documents within one unit of change into slimmer documents so that we don't have the, oh, I can display your blog post once I load the 356 megabytes worth of comments that I'm only going to show you the first 10 of. So then my last area of focus is NServiceBus Saga storage. You may remember that book I mentioned. So how many people in this room are familiar with NServiceBus to some level? Okay, quite a bit of people. For those of you uninitiated, NServiceBus is a framework for creating distributed systems. This is glossing over a lot, but it's basically transactional message handlers with auto retry, with publish subscribe features. And Sagas in particular are like correlated message handlers with shared state. So you can almost think of it like your ASP.NET session state. Multiple HTTP requests are coming in that don't know anything about anything, and with that session ID, you tie them all together and they have shared state. But unlike session state, Sagas are actually good. So this is the Saga storage interface that NServiceBus has, SagaPersister. It is very CRUD-like in its API. It's got 2 getters, a save, an update, and a complete. And all of those operate on an I-contain Saga data, which is an interface that says NServiceBus is going to need an ID and an originator and an original message ID, and that's just the stuff it needs to send stuff where it needs to go. It's not really important for the purposes of what we're talking about today. But we're going to need to take this stuff and we're going to need to store it somehow, transactionally. So the history of Saga storage is that in NServiceBus 2.0, which was the first version I used, it was SQL storage via Fluent NHibernate. Agreement? So I didn't like that, so I built my own based on XML serializer. My XML serializer one, I had to do stuff that even though I hadn't even heard of RavenDB yet, was very RavenDB-like. I shoved it into an XML thing, and then for all of the properties that you had to look it up by, I had to throw that in a second table so that I could look it up. So that was kind of like the Lucene part. So in NServiceBus 3, RavenDB SagaPersister became the default, and the villagers rejoiced, and it was great and wonderful and excellent. So back to the old days, when we were trying to do this in SQL Server, how would this work? So this is a very simple Saga where we're basically, we mention this in training all the time. It's like we're waiting for the order build and the order received and the order build event to come in. When both of those things happen, we can say, okay, now we're ready to ship the order. So we're going to do that in the stupidest way possible and say when we get 2 messages, we are done and we can proceed. So we're storing the int messages received. And then we have all of those other properties on the class that we need to have in order to implement I-contain Saga data. So how does this look? This is what Fluent NHibernate creates. That's fine. It's got a primary key on the ID, and then the originator, message, blah, 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 blah. It's great. Stop smiling at me. Did you notice that virtual keyword? Without that, Fluent NHibernate would throw some stupid exception saying that, quote, database was not configured through database method, which led many developer to go, what? Basically, NHibernate needs those because it creates proxies on top of this object, and without a virtual thing to override, it has no way to do any of its stuff. And so, of course, the error message is useless, and it's just bad. But that wasn't even the problem, in my opinion. My problem was like, why do I have to type all these properties all the time onto every single one of my Saga data classes? Can't I just put this stuff in a base class? That would really be nice. So let's do that. Let's have it implement or inherit base Saga data. That would be a lot better. No more duplication. Duplication is bad. So then we get 2 tables. That's what Fluent NHibernate does. We get the base Saga data, which I can't even remember if I think multiple Sagas would share it, but that's neither here nor there. And then we get my Saga data with the ID and the messages received, and they're linked by a one-to-one. And so now, remember that these are transactional message handlers. So every time we are processing a message, now instead of holding a lock on 1 table, we have to hold a lock on 2 tables. That's not great. Even with automatic retry, I don't like to, on purpose, create concurrency problems. So fine, I guess I'll put it all back in the same class again. But now I realize that just counting the number of messages received is not the best idea, because maybe there's other messages that are implemented by the Saga, or maybe a million different things could happen, or maybe order accepted could come in twice, or maybe there's an order canceled, or whatever. So we really need to store a list of the messages we've received, and not just the count, so that we can say when we get order billed and order accepted, then we're done. Okay, so now we've got a list of strings. So what will Fluent NHibernate make out of this? Do you notice this list of string? How would you model that if you were doing it manually? Well, you have two choices. You can go like comma separated, which will work great if your data contains commas. Or you can do bar separated, because that's less likely to happen. Or you can create another table. But Fluent NHibernate has no way, with the stuff that it knows, to take that list of strings and turn it into another table. So instead, this came up on the NServiceBus message boards also many, many, many times. We have to create a whole class for this, and the ID for this received message class must be a GUID. And then you have the virtual string, of course, message type received. And so then that'll finally work, and you get your my Saga data and your received messages, and they're related like that. And now we're right back to the two-table problem. And so what if our Saga data actually needs to be more complex than this? What if we need to lock against 5 tables, 6, 10? That'd be a little crazy, but it's happened. So that's where Raven is awesome. We can just say, there actually is a base class, contains Saga data now, and it actually works. I actually think in the current version of the SQL persistence, because that's still around, they use the table per top level class now, but that's neither here nor there. Or with Raven on the bottom, we can even do a hash set of type, because Raven doesn't care. Raven can do that. SQL Server can't serialize a hash set of type. It'll freak out. But Raven can do it just fine. So let's go back to SagaPersister for a moment and notice this, the second getter. If we're doing a timeout or something where we already know the Saga ID, it's very easy to look up the Saga by its primary key, basically, but that hardly ever happens. Most of the time, you have the message coming in saying order billed, and it has an order ID, and you need to match the order ID on the message coming in with the order ID on the Saga that's out there. So you need to look it up by this property. So let's do a little more real-life Saga now. Well, that's actually what I've been talking about the whole time, so yay me. So we're still waiting for order accepted and order billed and publishing and order shipped. So we have our shipping data Saga, and we have our order ID with this unique attribute on top. And so that's an NServiceBus attribute, and each SagaPersister is basically charged with figuring out how it's going to do its uniqueness in order to consistently get back the same document for that property. So all we need is our order ID with the unique, and then the message types received. So the way we can deal with this is by creating pointer documents. And this is what NServiceBus does. And I've color-coded, I took out the actual GUID values because those are gross, and I color-coded it so you can kind of see how they relate. So on the top, we have the document that says the shipping, this is a shipping data Saga, and its order ID property has this GUID, and it's not really a GUID, it's just like a hash that's turned into a GUID. And then we know that the Saga ID is this, and the unique value is that, and that the Saga document ID is the green thing. And so if we load the top one, which we can always construct from our message data, then we can do an include and get the bottom one, and we bring back all of our Saga data with no database locks and completely consistent. So another example where this comes into play is OpenID or OAuth. Login with a third-party identity also requires this kind of pointer document modeling. So OpenID identity URLs make for horrible document IDs because Raven is based on HTTP, and if you try to put a URL in HTTP, that'll get gross. but you can use an SHA-1 hash to get a fairly unique identifier. I think I looked up, you would have to get hit by lightning like 16 times before you would be as likely as having an SHA-1 hash collision, so that's fairly good for me. An easy way to do this OpenID stuff with MVC5, if you don't like the entity framework, as I do not, is to use the ravendb.asp.net.identity NuGet package, which I created, and you can get the source there and make fun of the author, maybe send me a pull request, be a fun time. So how does that work? At the top, we've got the application user document, basically my user document, and this shows that I have a list of logins, and one of them is Google, and then the provider key is blah, 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 that. Then we have another document type called identity user logins with our SHA-1 hash, which I shortened, and the user ID, which the user ID points to the ID of my user document, and the provider key. So this allows us to load the top document and then just show the list of, here are your ways of logging in. Or when we're logging in, we can load the bottom document with an include on the top document and know that we are logging in with the correct credentials. And the NuGet package takes care of that all for you. You basically strip out the entity framework stuff and throw this in, and it just works. So what can we learn from our kind of a long-winded talk through NServiceBus? Document databases are ideal for storing random objects with little friction. They're perfect for that, and that's why NServiceBus chose them. But unique constraints are a special case, and we have to treat them specially to ensure consistency. So that means either custom pointer documents, or you can use the unique constraints bundle for more generic functionality, although if I care about the content of the documents and I'm not just using it as a means to an end, I usually roll my own, because then I can put another property in it or do whatever I need to make that application work better. And use my NuGet package for OpenID. So my final thoughts are that document modeling is not the same as SQL, and if you try to make it so, you will fail, so don't be that guy. Above all else, thinking about how and why data changes. That means units of change, transactional boundaries. Everything else is kind of window dressing. And document modeling is a skill that requires practice, and you get better at it through experience, just like SQL, really. So model things like you would in the real world. Don't be afraid of trying and failing. And one thing I do in almost every project is I create a fake data controller where I just create my whole world in RavenDB, just a bunch of document stores. And I am not afraid to blow away the whole thing and recreate that at a moment's notice. I'll try something and go, oh, that's not working, and just blow it away, start over new. It's a lot easier to do with Raven than it is with SQL Server. That's it. Questions? Favorite beer? That I made, or my favorite one that I made? Probably the oatmeal stout I have in the fridge right now. It's delicious. I want to try adding chocolate and vanilla to it. Yeah. You don't guarantee the sequence of the messages you received. You cannot count. You can't count on them to arrive in any given order. So you need to do things like, I received an order build message. That's interesting. I haven't received an order accepted yet, which should, in theory, come first. So I would then create the Saga and say, I guess I'm waiting for an order accepted message before I can continue. So NServiceBus Sagas kind of bring some of those race conditions to mind and force you to handle them. Great product. You should read my book. Other questions? All right. Thank you very much.